Hi, my name is Kenneth Kirby, and this is Lab 2 Lines of Charge for Physics 2212. For the introduction to this lab, the purpose of this lab was to expand on topics presented in Lab 1 and attain a more accurate measure of these charges and forces taking place in everyday objects, such as tape. The experiment involves the use of Coulomb's law, Newton's second and third laws, and especially the formula for electric field for a rod to determine the charge on a piece of tape more accurately than we would if it was in a point charge like from Lab 1. The results of this lab were that the charge on the tape was more accurately matched to the force of gravity when using the rod-based electric field formula and Newton's third laws. For assumptions and fundamental properties, we had to assume that each U-tape had about the same amount of charge and that each U-tape made was had an evenly distributed charge along the length of the tape. Some fundamental principles include Coulomb's law, Newton's third law, gravitational force, the electric field formula for a rod, and superposition, or the law of superposition, involving multiple charges or point charges on the piece of tape. For the experiment or actual procedure used, this was very similar to Lab 1, where we were to create two strips of U-tape and attach one of them to the tops of two separate standing textbooks to determine the interactions between the two pieces of tape and when they would start affecting each other. For some observations, some of our constants and measurements involve K equaling 9 times 10 to the power of 9, the force of gravity, length of each strip of tape, mass of one tape, and the record that we found that was that the top strip bound by the books floated at 0.028 meters apart. Some data and calculations that were involved in this lab included the force of gravity on the tape and the charge of the U-tape, which were both things that we found in the previous lab. The charge on the U-tape before was determined by a point charge, but we also were able to determine this using the electric force formula for the rod, and this calculation came out to be 2.5177 times 10 to the negative 8th power. Some of the results included in this lab were that based on the computational model, the force or the electric force on the top piece of tape was 1.7569 times 10 to the negative 3 newtons, and the gravitational force was 1.962 to the negative 3 newtons, which was fairly similar, or at least a lot closer than if the point charge formula was used, which had about 24% accuracy. Some what if questions involved in this lab. First off, what if you had modeled each of your tapes as a single point charge like in the previous lab? From the data and calculations slide and the previous lab, we saw that we would get 1.307 times 10 to the negative 8 coulombs. And using Newton's third law, we can determine its accuracy by seeing if it's equal to the force of gravity. When comparing this value to the one we get when we use the rod-based electric field formula, we get a 49.1% margin of error versus a 94.6% margin of error. And this is determined by finding the charge that results in an equal and opposite force to the force of gravity and then comparing these charges to it. And then we have, why do these estimates differ? Which value is more likely to be closer to the real value, and why? The point charge estimate is lower because it only takes one charge's interaction on another into account. The rod charge estimate is able to consider many point charges and their interactions with each other, which brings us much closer to real-world interactions and conditions. This is partially explained by the law of superposition. Some of the glow script code and the results that were found in this lab, you can see I have 3 Q's or 3 charges within the constant section, and this was because the first one was from the point charge formula, the second one was using the rod formula, and then the last one was a guess and check method to determine exactly what charge would give us the same electric force as the force of gravity. And for the last slide, we have some of my methods in order to attain the model or the diagram pictured earlier. We iterated through each piece or each piece of charge in the top tape, which I used 100 different charges or piece charges on this tape, and we ended up calculating the electric field at the location of each top particle, and ended up adding that all together in order to get the net electric field. And then in the end, we kind of created these arrows in order to picture that. Thank you.